Right, so 2023 advanced level logic gate question. So let us discuss this. So you can please take out your past papers and do the question with me itself, right? So here they have mentioned a circuit with three inputs. So A, B, C are the inputs and one output is to be designed, it seems. The output should be equal to 1 when the binary value combination of the three inputs is either 1, 3 or 6. So if the binary inputs of the combinations that you are putting on the truth table, if it is equal to 1, 3 or 6, in that cases the output itself should have the value of 1. In all other circumstances it is going to be 0. So let us see how to draw this. First of all, I wanted you guys to pause the video and have a try, and after that you can play the video and check your answers, right? So let us see this. So this is a 3 inputs. So if you know, if there are 3 inputs, how many combinations are possible? That is 2 to the power 3 is equal to 8 combinations, right? 8 combinations are possible. First of all, you need to have an idea on this, right? Then let us draw the truth table, okay? So when it comes to the truth table, you have the inputs A, then we have B, then we have C, and the output is Z. Alright. So let us draw this. So you know the first combination 0, 0, 0, then 0, 0, 1. Then 3, 4, 5, then 6, and finally 7. So if you take the count, there will be 8 combinations here, okay? Right. So then, according to the question, if the input 1, 3, 6, that means see here, if you convert this binary 0, 0, 1, if you convert this binary 0, 0, 1, right? What are they saying? The value combinations of 3 inputs is either 1, 3 or 6. The output should be 0 for other cases. The output should be equal to 1, it seems, when the binary value combination of the 3 input is either 1, 3 or 6, right? Okay, fine. Now look here, this binary. If you convert this into decimal, right, 1, 2, 4, so this is going to be 1. So in this case 1, it is going to be 1. The output result is going to have the value of 1. Then they are saying 3. 3 means, look here, this combination, which is 0, 1, 1. So 4, 2, 1. So if you convert this into decimal, 2 plus 1 is 3. So 3 means here also the output is going to, Z is going to have the value of 1. Very simple as it is. So you need to know the binary to decimal conversion. By looking at this, now you must be able to do this, okay? Then next one is 6. 6, okay, fine. Here see 4. Now if you look this combination 1, 1, 0, so 4, 2, 1. So 1 means you need to take the count of these 2. So 4 plus 2 is 6. So in this case also the Z is going to be having the value out, the output Z should have the value of 1. In all other cases it is going to be 0. So this is a truth table. Very easy question in 2023 when it comes to a truth table, okay? Then you can check your answer 0, 1, 0, 1, 0, 0, 1, 0. Right, we are done with the truth table. So now, dear students, let us go for the next one. So now they have told, so this is 5, question number 5, A, first one. Now now let us go to the second one. Now in the second one they are saying, draw the Carnot map. Draw the Carnot map relevant to the above circuit according to the following format. So they have given a format. So you can design your own format in that scenario. You need to use the format given by the examiner without making any other changes. So just copy the same format to your paper. Then let us complete the Carnot map as well. So here Let me erase this stuff now. And let me draw the corner map here. So, ABC. Right. Then we are having 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Right? 0, 1, 1, 1, 1, 0, then 0, 1. Now here, now let us fill the values. Now first of all, you know, there are only 3 ones. So if you fill the 3 ones to the corner map, you can put the remaining other things as 0. So that is one of the easy. Now look here, A is 0, B is 0. That means what? See here, A is 0, B is 0. C is 1. C is 1 means here. In that case, the value of Z is 1. Put 1 here. Right? Then next one. Look, this one, focus on this. A is 0, B is 1. A is 0, B is 1. Then A is 0, B is 1. C is 1. That means this scenario here also it is 1. As simple as it is, right? Then this one. A is 1. So dear students, now here this is representing A, this is representing B. For the others one also same. This is C. Alright? A is 1, B is 1. So A is 1, B is 1. C is 0 means this scenario. So here put 1. Now for other zeros, should you need to find? No need. Why? All other remaining are 0. So just put 0. That is the easiest way, and also you can save time at your final examination. Right? Now, what are they saying? Using the corner map, complete the corner key map relevant to the above circuit according to the following format. That one okay, fine. Then using the corner map, derive the most simplified product of sum. So when it comes to the product of sum, our focus is 0. Our focus is 0. Expression for the output is set. Show the loops clearly on the corner map. So now they are asking to simplify and get the simplified product of sum using the corner map. Let us see how to do that. So here, look here. This 0 can go with this 0 and make a group. And also this 0 can go with this 0 also it can make a group. But look at this 0. This 0 can go only with this 0 and make a group. Therefore give the priority to this 0 and make a group like this. Fine. Then look here. Then you can make another group here. This is another group. Then here you can make a group. So these are the 3 groups that you can make. Now there is also another alternative answer for this, but I will be doing the question using taking this alternative answer, right? So then they are asking to get the simplified POS. Now let us see. So Z is equal to, now look here, which is not changing. Our focus is 1, no? 1. Why? Because we are using the product of sum. So our focus is 1. So here see, here you have 0, here you have 0. It is not changing. So take that, here you will be getting A. So when it comes to product of sum, you need to get plus here. Right? Then here, now here you can't take B. Why? Here you have 0, here you have 1. If it is changing, you can't take dear students. Look here, here it is only 0, nothing to change, because this is C, this is horizontally, only you have this one, nothing to compare. So here C, 0, so 0 means C, so A plus C. That is 1. Then dot. We are done with this. Now let's move to the next one. Next one, if you consider A, look here. A is 1 and here also 1. Not changing, but A has the value of 1. But when it comes to product of sum, our focus is 0. So if you need to convert the 1 into 0, you need to bar it. Therefore, you need to put A bar here. A bar here. Plus. Right? Now look here. Here for the C we have 1. So our focus when it comes to product of sum, it is 0. So you need to convert 1 to 0 means for C you need to put C bar. So A bar plus C bar. This is another one. Then the final one, let us consider this. Now here you have 1 and 0. So here you can't compare anything, so you need to take both of them. So for A you have 1, so convert it into 0, then it's going to be A bar. Then here you have 0, it is fine because in product of sum our focus is 0, so keep it as it is, so B plus B. Now here 0 and 1 are changing, so you forget about C. So this is the final answer, dear students. That is using the Carnot map for the third one. Derive the simplified POS expression for the output Z. So we are done with that. Okay. So Z is equal to A plus C dot A bar plus C bar dot A bar plus B. Right. So now it's the time for us to move on to the next one. Okay. Now what are they saying next? Draw a logic circuit for the simplified expression derived in third above. That means consider this simplified POS expression and use this and draw a logic circuit by using only NOR gates. So you can't use any other gates, right? You need to use only the NOR gates because the examiner has specifically mentioned you to do so. Assuming that the complemented input A bar, B bar and C bar are also available. So you need to consider that those also as available. Right, now let us see how to do that. So I am going to use the erase the truth table because it is no need for us, and also the Carnot map, and let me take only the simplified POS expression. Right? Alright. Now what is our simplify this one? This is Z equal A plus C dot A bar plus C bar dot A bar plus B. Okay. Now using only NOR gates, you can't use any other gates. Now imagine you have A plus C. Now how to show this in NOR gate? Take the NOR gate for an example. Imagine this is the NOR gate. Right, this is the NOR gate. Now you take the input A and C. Then what will happen? You guys know A plus C whole thing bar. Then if you apply the relevant law, it's going to be A bar dot C bar. Now look here, here we have A plus C, but here we are getting A bar dot C bar. Are they matching? No, they are not matching. So how to draw the NOR gate? Using NOR gate, how can you draw the logic circuit? I will say you the easiest way today. Right, how to do that? You guys know that, you students know that A double bar is equal to A. So for this simplified POS expression, if I put double bars, what will I get? I will get the same A plus C dot A bar plus C bar dot A bar plus B. So there is no any changes if I apply the double, if I put double complement up. Okay, so we will be getting the same A plus C, we will be getting the same A bar plus C bar, and you will be getting the same A bar plus B. As simple as it is. So let us use this way and do this. Now let me keep the top bar as it is. Let me keep the top bar as it is, and let me break the bar which is below the top bar to these, like this. Okay, okay, fine. Now using this logic, so now you know these dots will become plus, these dots will become plus. Right, so then you will be getting A plus C bar plus A bar plus C bar, then another bar at the top plus A bar plus B holding bar, then one bar at the top. Right, now let us see how to do this. Now you need to draw NOR gates for these things. Then if you draw NOR gates for these three, you will be getting automatically the logic circuit. Let us see, have a try how to do that. So I wanted you guys to first try, then look at the answer. Okay, so let me take like this. So this is the answer for the B. Sorry, not B, fourth one. Okay, fourth one. Okay, fine. So here let me take A, then we have the B and C. Okay, fine. Now let me take this A and let me take this C, then make a NOR gate. Right, now look here, A is coming from here, C is coming from here, that is A plus C. So if it is passes through the NOR gate, it is going to be A plus C bar. Look here, we are getting that here, right? A plus C bar. So that's why if you follow this method for this kind of a question, then it's very easy for you to handle the question. Now we need A bar, dear students, but here we can't see A bar, so we need to get A bar. How to get A bar, I will teach you now. So look here, you need to get A bar. So you can use this way. Right. Now look here, A is coming, so A will come here, A will come here because it is breaking. Then here A plus A whole thing bar. So you know, when you apply the relevant law, A plus A whole thing bar means A bar dot A bar. When you apply the relevant law, and A bar dot A bar is equal to A bar. So see how we got A bar, how magical it is. Okay, very easy. After that, now let us also take the C as well, because we have C bar here. So let me take here C, break it like this, and here we are getting C. So here you will be getting CC. So here you will be getting C plus C whole thing bar. That means C bar dot C bar, which is ultimately C bar. So see, here we are getting A bar, here we are getting C bar. We are achieving the goal. Then what we are going to do, pass both of them. Why? Here we are getting A bar, here we are getting C bar. So we need to achieve this. Then you need to pass both of them through a NOR gate. You can't use any other gates because the examiner has specifically mentioned you to use only NOR gates. Okay. Then what is happening? You know, here we have A bar, here C bar is coming. So here it is going to be A bar plus C bar, and another bar will be coming because this is not OR gate, this is NOR gate. Then what is happening? You know, here A double bar means A, plus will become dot, C double bar means C. So A dot C. Here we will be getting A dot C. Now look here, before going to the A dot C, here we got A bar plus C bar whole thing bar. Look here, here also for the output we are getting A bar plus C bar whole thing bar. So see, we have drawn this as well. See how logical it is. So if you follow this way, it is very easy for you. We got A bar, A plus C whole thing bar, and we have got here A bar plus C bar. Then another whole thing bar. Right. Now before going to the next one, let us get this as well. A bar plus B whole thing bar. Right, that's how it is. A plus B, sorry, A bar plus B, then whole thing bar. Right. So here we have already got A bar. So let us take that down. Okay. Then we need what? We need B. So let me take the B from here. Then pass it through an OR gate. Then what is happening? Here A bar is coming. Here you can see B is coming. So A bar plus B whole thing bar. See, here also we are getting the same answer. Here also we got the same answer. A bar plus B whole thing bar. Here also A bar plus B whole thing bar. So see, we have now achieved all these three here. So if you are wondering how to draw the NOR gate, the logic circuit using NOR gates at the final examination, you can use the strategy or the tip that now you have learned to handle at the final examination if you are getting the same kind of a question, right? Then now let me erase this, because now I need to draw the complete NOR gate. Anyhow, let me write the simplified POS expression. That is, let me write it down, dear students. Z is equal to A plus C dot A bar plus C bar dot A bar plus B, right? A bar plus B, right? Fine. Now what we are going to do, pass all of them through a NOR gate. Pass all of them through a NOR gate. Why? Because if you can remember just now what I erased, you saw a bar at the top. So that bar only now we are going to achieve by placing the NOR gate. So now let us pass the NOR gate. Right. So you can say here is that the output. You can show it. Okay. Now look here, dear students. So here you are getting A plus C bar. Here you are getting A plus C bar. Here you are getting A dot C. So when you simplify this, okay, A, if I break the bar here, dot plus will become dot. So bar A double bar dot C double bar. So double bar means A double bar is A. So A dot C. So here you are getting A dot C. Here you are getting A plus C whole thing bar. Then what about this? Here you got A bar double bar plus B. So if you break the bars, A double bar dot plus will become dot B bar. So you know A double bar is equal to A. That means A dot B bar. So here it is coming A dot B bar. Now what you need to do, add all these things and make complement. Not it. Then what will happen? Look here, A plus C whole thing bar. Then you are going to plus it, because this is NOR gate. Then A dot C plus A plus B bar. Then this is NOR gate, put a bar top of this. Then look here, I will break the bars now. A plus C whole thing double bar plus will become dot A dot C bar plus will become dot A dot B double bar. Okay, so you guys know A double bar is equal to A. So A plus C whole thing double bar is going to be equal to A plus C. Okay, then dot A dot C bar whole thing bar. So if you break this, A bar plus C bar. Okay, dot A dot B double bar. B double bar is equal to B. So A dot B. Sorry, small mistake in the sense, here there is one bar at the top now, so that bar should come for this A as well when you are breaking. So I missed that. So it is going to be A bar dot B. Now look, here you are getting A plus C. You are getting A plus C. Here you are getting A bar plus C bar. Here also you are getting A bar plus C bar. Here you are getting A bar plus B plus B. Now here I made a small mistake. We have a bar at the top, so this dot should become plus, right? What was that, beta? Sorry. This is correct because A plus C. Then here A dot C. This is A dot B. Right? Okay, fine. Then here, what in the sense, we are having a bar at the top, right? We are having the bar at top. So here A dot B bar, that's going to be double bar like this. Okay, so when you are breaking this bar, here we will get a bar, this dot will become plus. That's where we went wrong, so now I have corrected that. Okay, so then here you can see here also a bar plus b, here also we got a bar plus b. So see this proof. Now you don't need to show this proof in your exam. If you draw this logic circuit, that the examiner will give you the marks. But if you want to check whether your answer is correct, like on a working paper, you can quickly check, do and see whether your answer is correct, right? But you don't need to show these steps at the final examination, right? Because directly Karno map is given. So this proves that our logic circuit is correct. By the simplified, we have passed the values and simplified, we got the same answer. Here also we are getting the same, right? Now let's move to the next one. Now let me erase this. Alright, so now what are they asking? So let's go for the more, dear students. Let's go for B now, dear students. Using Boolean algebra, show that a bar c plus a bar b plus a b bar c plus bc is equivalent to c plus a bar b. So let us see how to do that. So what are they saying? A bar c. This is B question. A bar c plus a bar c plus a bar b, a bar b a bar b plus a b bar c, a b bar c plus bc. So this is what they have given, right? A bar c plus a bar b plus a b bar c plus bc. Then now you can see that c is common for 3. What's the law? Distributive law. Make them common, get the common, right? So before getting the common, let me rewrite so it is easy for us to apply the distributive law directly. So let me rewrite this as a bar c plus a b bar c plus bc plus a bar b. Now apply the distributive law. So you can see c is common. Take c common out. So here we will be getting a bar plus here we will be getting a b bar, and here you will be getting b. Then here this is as it is a bar b. What is the law? Distributive law. Right. Now let's move to the next one. Next one, in the sense you need to simplify it and prove that, right? You have to prove that it is equivalent to c plus a bar b. Until that you need to keep on moving. So now you know we have learned a law called redundancy law, right? What is the law? Redundancy law. If you have forgotten this, you can, I have done a separate video, you can go to our YouTube channel and look that, okay? So according to this redundancy law, a plus a bar b is equal to a plus b. What? A plus a bar b is equal to a plus b. That is the redundancy law. Now look here, it is not the same way it is given in this question, but you can apply the same redundancy law for here. This here it is a bar plus ab, sorry, ab bar, a bar plus ab bar. So that is equal to a bar plus b bar, right? You can apply the redundancy law. Now if you are wondering yet how I applied, right, you can draw the truth table which I have taught in the previous YouTube video. You can draw the truth table and check whether you are getting the same values, right? You will get definitely by the same law is applied. So then here for a plus a b bar, a bar plus a b bar, I can write a bar plus b bar. I can write a bar plus b bar. Then this plus b is going to be as like that itself, and this plus a bar b is also going to be like that itself. So it is going to be the redundancy law. As simple as it is. Fine, move forward. You can't stop now. See, now here you have b bar plus b. We have learned this a bar plus a, right? So here b bar plus b. So dear students, b bar plus b is equal to 1. What is the law? Inverse law. A bar. So a bar plus a is equal to 1 means b bar plus b is also equal to 1 plus a bar b. What is the law? You can say the law is inverse law. Inverse law. Move forward, don't stop. Then you know a bar plus 1 is equal to 1. What is the law? Identity law. So here you can say 1 plus this a bar b is going to come as like that itself without any changes. The law a bar plus 1 is equal to 1. The law is identity law. Identity law. Right. So c into 1 is c. So c plus a bar b. So look, we have achieved the final answer. So this is what the examiner is expecting from you. So this is how you need to do to achieve the final answer. So now let us move to the next one. So let me erase this stuff. Right. Interesting question is given in 2023 that comes with a flip-flop. So consider the flip-flop circuit shown on the right. So they have shown it on the right. Assume that this, so let me also draw the flip-flop, right? Let me also draw that. Right. Okay, fine. So here we are doing the answer for the C. So the R, you are having R here. So I wanted you guys to draw with me. Now here it is given, right? So in 2024, sometimes the examiner can ask you to draw, sometimes possible, no? So just draw with me. Yes. Right. Then this is going here. So here you are having the Q, and here you are having Q bar, and this one is coming here, right? So this is the flip-flop Q bar, and S is given. Now, what they have told, assume that the S input is 1 and the R input is 0. S input is 1. S input is 1 and R input is 0. Right, like this. Then what are they asking? What will be the output at Q? What will be the output at Q? Okay, fine. How to do that? Now let us see how to find that. Now Q. Now if you notice the Q means this one. They are asking this one. So if the Q is for R. See, R is going. So R plus, what is this? Q bar. R plus Q bar. What is that gate? Not O gate, that is no gate, dear students. So put a bar and stop. Right, okay. This is what. Now look here, you know what is R? R is given, R is 0. Plus, do you know what is Q bar? Do you know what is Q bar? You don't know. Why? You don't know what is Q bar because you don't know what is the value for Q. because S is given, Q is not given. But you can't find Q bar without Q. But unfortunately, we are also finding Q. So can you do this using this way? No. Then you need to use your brain and try it in another way. So now let us go for Q bar and check it. Without finding Q, dear students, let us find Q bar. So if you know Q bar, the opposite is going to be Q, right? So Q bar is equal to what? S plus what? S plus this Q. You are see Q is coming as the input here. Q. S plus Q. This is not OR gate, this is NOR gate, so put a bar at top. Alright. Do you know what is S? S is 1, dear students. Very clear. Plus, again, do you know Q? Now you will be wondering, we don't know Q, no? Right, but you know what law? You know identity law. You know identity law. So dear students, according to identity law, you know A plus 1 is equal to what? 1. A plus 1 is equal to 1. So for this Q, this Q can be anything. This Q can be 1, this Q can be 0. Anyhow, for here you need to get the answer as 1. Here you need to get the answer as 1. Okay? Because according to identity law, you know A plus 1 is equal to 1. So Q can be 1 or 0, it doesn't matter. Anyhow, you need to get the answer as 1. So here we are getting the answer as 1. But, wait. What is the bar of 1? That is 0. So what is Q bar? Q bar is 0. But, is the examiner asking you Q bar? Examiner is asking Q. So what is Q? If Q bar is 0, Q is 1. Done. Very easy. Then next one, what are they asking? What will be the output at Q? First one we have found the answer is Q is equal to 1. Next one, what are they asking? What will be the answer? No? What will be the output at Q? What will be the output at Q if the S input is now made 0? Now the S input they are making 0, then they are asking what will be the answer at Q? Very simple. So let us find that. Let me erase this stuff before that, right? Okay, let us see. So here we need to find Q and S is 0. For before previously we know for Q we got 1. For Q we got 1 and Q bar we got 0. Right? Remember that. Okay. So now they are saying for S they have changed to 0. R no any changes, so it will be as 0 as like that before itself. Okay, no any changes made to that. So they are asking to find your Q. So how is Q formed? Look here. Q is formed using what? R plus Q bar. R plus Q bar. But this is not OR gate, this is NOR gate, so put a bar at top. So you know R previously it was 0, so now also it is 0 plus Q. Q bar. Q bar what? Q bar 0. Before we previously found, so it is going to remain the same, so Q bar 0. Then put a bar at top. You know 0 plus 0 is 0, but what is the opposite of 0? That is 1. So Q is going to be 1. This is the answer we have found. Q is 1. Then what is going to be Q bar? Q bar is 0. But here the examiner is asking only the Q. Then third one. So no need to write Q bar. Okay. Third one. So third one, what is the examiner saying? What will be the output at Q? At Q when the R input is now made 1. And now they are making the R input to 1. There is no any changes for other things. Now what is the what will be the output at Q? They are asking. Right, fine. So Q again is equal to R plus Q bar, but this is not OR gate. You can see no gate here, no gate. So put a bar at top. R is 1 plus Q bar is 0. Previous it was that. So put a bar. 1 plus 0 is 1. 1 bar is equal to 0. So for here, Q will be getting 0. Then Q bar is going to be 1, but here they are asking only Q. So the answer is 0. So we are done with the 2023 logic gate question, right?